In this video, I would like to show you an easy way of using multithreading in your Flutter projects. So let's start by responding to the question, what is multithreading? Well, to put it simply, it's the ability of a single core in the CPU to provide multiple threads of execution concurrently. It basically means that we can run multiple tasks simultaneously on a single core of the CPU. So, why do we need multithreading? Let's say we have to perform many heavy computational tasks, and if they're being processed in a single thread, the app will probably freeze or the frames will drop. To prevent such situations, we need to transfer some of these CPU-intensive tasks to the other threads. Dart, despite being a single-threaded language, can perform tasks in multiple threads using isolets. An isolate is what the whole Dart code runs in. It's like a little space in our machine with its own private chunk of memory and a single thread running an event loop. In a lot of other languages like C++, we usually have multiple threads sharing the same memory and running whatever code they want. In Dart, though, each thread is in its own isolate with its own memory, and it just processes events. Many Dart apps run all their code in a single isolate, but you can have more than one if you need it. If you had a computation to perform that's so enormous it could cause you to drop frames, you wouldn't want to run it in the main isolate, but you'd prefer to use isolate spawn or Flutter's compute function, both of which create a separate isolate to do the number crunching, leaving your main one free to rebuild and render the widget tree in the meantime. That new isolate would get its own event loop and its own memory, which the original isolate, even though it's the parent of the new isolate, isn't allowed to access. When it comes to the origin of the name isolate, these little spaces are called so since they're kept isolated from one another. In fact, the only way they can work together is by passing messages back and forth. One isolate will send a message to the other, and that receiving isolate process is the message using its event loop. This lack of shared memory may sound kind of strict, especially if you're coming from a language like Java or C++, but it has some key benefits for Dart coders. For example, memory allocation and garbage collection in an isolate don't require locking. There's only one thread, so if it's not busy, you know the memory's not being mutated. That works out really well for Flutter apps, which sometimes need to build up and tear down a bunch of widgets really quickly. So that's a basic introduction of isolates in Dart. It's important to note that Flutter Web doesn't support isolates, which means that there's no point in trying to run the following app on the web, as we will get an error. So I've just made a simple counter app like the one given in the sample project. I've just removed the stateless widget, that's all. Now, let's say we have to perform lots of heavy computational tasks in a function. And in order to do that, we need to move some parts of the computation to another thread so that there is less load in the main thread. So let me create a function and call it multithreading function. It's just going to accept a number, so let's create a variable called n. Inside the function, I'm simply going to create a variable named count and initialize it with 0. I'm also gonna create a simple loop from 0 to n. And the count ++ will increment the value of the counter. Now, if count mod 2 equals 0, then we will print the value of count. The logic means it can print the even numbers from 0 to n. So this is our function, and let's say, hypothetically, it's very computationally heavy, and we would like to put it in another thread now. Now to do that, Flutter isolate comes into play. In the init state, I'm gonna write isolate.spawn. Let's import the isolate function. It basically accepts two positional arguments. One is the function which we want to isolate. That is to say, run it in another thread. So let us write multithreading function. And the other argument would be the value that goes to the function. That is n. I'm gonna write, let's say, 100. And it's done. Finally, let's restart the app. You can observe that when the app runs for the first time, it prints all the even numbers on the console. And it's important to note that our multithreading function is actually running on a different thread, even though we cannot see it. We can also put the isolate function somewhere else. So let's cut it and paste it within this onPressed function. Let's restart the app one more time and observe what's gonna happen. So whenever we press this floating action button and look at the console, we observe that all even numbers till 100 get printed. With this video, we can conclude the multithreading module. I've also attached a blog to the resources of the video if you'd like to read more on multithreading and get to know how it can be used in other areas, like while parsing data from the network. See you in the next lesson.